Good evening, all. So the concept is dynamic programming, and which is a crucial algorithm technique covered in analysis and design of algorithms. And it is used to solve complex problems by breaking them down into a simpler sub-problems and storing their result to avoid redundant computation is all about dynamic programming. And here are the key concepts of dynamic programming. That is, we're going to discuss about what are the types of dynamic programming approaches we have and a few of the examples. We'll look into it. So when it comes to types of dynamic programming approaches, we have two types. One is top-down approach and the other one is bottom-up approach. Top-down approach is basically memorization, like recursively solve the subproblem and store the result in a table, like a Fibonacci series. That is an example for top-down approach. Whereas bottom-up approach, it iteratively solves smaller subproblems first and then build up the final result. Okay. So there is an example called as knapsack problem using a dynamic programming a table. We will solve the smaller subproblems first and then we build the final result. Whereas in top down, we recursively solve the subproblem and then we store the result in a table. That we call it as a top down and bottom up approach. So the examples of a few of the dynamic programming problems in NADA is we can get a solution for Fibonacci series problem, and we have a problem called as knapsack that can be achieved by using dynamic programming approach. We have so many other algorithm like Floyd-Warshall algorithm, matrix chain multiplication, like that we have. And you can see why do we have to use dynamic programming in NADA? Because effectively solves the problems with overlapping subproblems. That is one thing, and also it improves the performance of exponential. If we have exponential factor, it can be reduced to some polynomial factor like n square or to n. Okay, that we will be seen in the further lessons. So that's why basically to improve the efficiency of the algorithm, performance of the algorithm, we use dynamic programming, which is used in optimization problems like again knapsack and also scheduling algorithms also we see. And and we have one I can give you one real world example of dynamic programming. Like, imagine you are driving from city A to city B. Okay, so you want to drive from city A to city. You want to find the shortest path that takes the least time. Okay, so you want to find the shortest path that takes the least time, and there are multiple roads with different travel times due to traffic, speed limits, and road conditions. Okay, so how does Google Map quickly find out shortest and fastest route? The solution is through dynamic programming approach. Okay, so Google Map uses a dynamic programming combined with graph algorithm like Floyd-Warshall, the GCRAS algorithm, and which will effectively compute the best route. Okay, so here in this example, we want to go, assume that we want to go from city A to city E, and we first find the best path. Let us find whether we can go to A to B and A to C or A to D, and then we can reach E. So, and then we use the values to determine the best path to city E, like that. Okay, and we have one more concept here, the store and reuse concept. Okay, so assume that we already know the shortest path from city A to city C, and we don't need to calculate it again. So when computing the path from city A to city E, instead we just reuse the result already stored. Okay, this is the essence of DP, dynamic programming, which solves small problems first and store the answers in the memory and use stored answers to solve the big problems. Okay, so that those are the advantages of using this. And here we have Actually, optimal structure and also overlapping subproblem, two components are there here. Optimal substructure is nothing but a problem has an optimal substructure if its optimal solution can be constructed from the optimal solution of a subproblem. That we call it as optimal substructure. When a problem, it can be divided into subproblem, and for each of the subproblem there will be optimal solution, and that we call it as optimal substructure. Overlapping subproblem is nothing but the same subproblem is solved multiple times, and DP avoids redundant calculation by storing the result. That we call it as overlapping subproblems. As I said earlier, there are two types of DP, that is a top-down and bottom-up. In the top-down, what we do is we first recursively solve the problem and then we store the result in the table. But whereas in bottom-up, we're going to solve the smaller subproblems first and then we build the final result. So that's a completely tabulation here.